Very good afternoon. Today I'm going to discuss various topics of pointer. In last lecture, I already discussed about the basic of pointers arithmetic. Then I discussed the relationship between a pointer variables and an array for 1D and 2D both. Then we discussed array of pointers and implementing sorting using pointer variable. So these topics are already been discussed in my last lecture. Today I'm going to start my discussion with the topic pointer to an array. What is a pointer variable? We all know. Pointer variable is a variable which can store the address of another variable. That is the definition of pointer variable, right? So what is array of pointer? That we know already. It's an array of pointers, means each and every index of an array behave like a pointer variable. That means each and every index of an array can store the address of another variable. Now the question comes, what is pointed to an array? What is pointed to an array? The answer is, we can declare a pointer variable that can point to the whole array instead of only one element of array. So a pointer variable can be declared which can point to the whole array, note it down, which can point to the whole array instead of only one element of array. This is very much useful in the case of multi-dimensional array. Now we are moving to an example where we implement this concept pointed to an array. I hope the screen is visible to you. This is the declaration syntax of pointer to an array. PTR is the pointer that can point to an array of 5 integers, and it is necessary, note it down, it is necessary to enclose the pointer name inside parentheses, and the type of PTR is the pointer to an array. It's pointed to an array of 5 integers. So you have to write the pointer name within a closing parenthesis, just like here in star PTR, which is in closing parenthesis, and after that the size, which what it means, the size 5 means PTR is a pointer to an array which is basically points to an array of size 5, and the data type int says the array must be an integer. So what we conclude? We conclude ptr is a pointer to an array which basically points to an array of 5 integers. And the line number 5, I declared int star p. What it means? It means p is a normal pointer variable. It's not a pointer to an array, it's a normal pointer variable. But the next line, that is line number 6, the highlighted line, this line says that ptr is a pointer to an array of size 5, because pointer to an array, we came to know that it is a kind of pointer which is not pointing to only one element. Instead of that, it is pointing to an array. So definitely we must have to mention the size of that array. Here I mentioned the size 5, which means ptr is a pointer to an array which basically points to an array of size 5, and the array must be integer because the data type says it's an integer. Next line, I have initialized an array 11, 22, 33, 44, 55. These are the values. And then after what I have written, p equal to arr and ptr equal to arr. Look, the difference, both are the assignment, but these two actually means the different things. The first line, p equal to arr, that we already aware about the line, which means it is basically equivalent to what? Is basically equivalent to p equal to ampersand of arr 0, right now? P equal to ampersand of arr 0, because we know array name is actually a constant pointer which points, rather which stores the address of 0th index, rather base address of an array. So p is nothing but a pointer which is actually pointing to base address of an array. That's clear to us because we already used this in our previous lecture. Second one, ptr equal to arr. Here ptr is a pointer variable, such a type of pointer which is basically pointing to the entire array. How we came to know that it is pointing to an entire array? Look, in the very next line, I have printed the value of p and the value of ptr. Both are pointer variable. So that's why it is basically the value is unsigned integer. So I have put the control string as %u. Next, what I have done, p plus plus, and in very next line I have done ptr plus plus, p plus plus and ptr plus plus. Try to understand. P, what p points? P points to the first element of the array. What ptr points? Entire array. So when I'm incrementing ptr, definitely it will increase the size. How many bytes? 5, number 5 into size of each. Size of each will be here. How much? 4 bytes, because integer. In this platform, integer takes 4 bytes. So the ptr will be increased by 20 bytes, where p will be increased only 4 bytes. Am I clear to you? Again, I am repeating. P, what p is points? P is basically pointing to the first element of the array. What ptr points? Entire array. If you print the output of this line number 10, both will give you the same result. The value of P and the value of PTR both are same, but meaningfully they are not same, because P is pointing to the element of 0th index, whereas PTR is pointing to the entire whole array. So when I'm incrementing PTR, it definitely points to the, if it points, starting point is here, when I'm incrementing PTR, that means it points to after 5 element, that means 6th element it should point. So if each element, each and every element takes 4 bytes, so 5 element will take how much byte? 20 bytes. So the result will be PTR equal to PTR plus 20, and in case of P plus plus, it only points to the next element, matlab element of index 1. So that's why it will give you the result, that is 4 bytes advanced, 4 bytes advanced than the current one. So execute the program, will show you the result. Look, what is P? Sorry, is it visible to you? So let me share the screen. Yes, I hope now it is visible to you. So PTR, what is the value of P? What is the value of P? It is 6487584, and the PTR is at at the time PTR is remain same, 6487584. But when I am incrementing P, P is pointing to the next element, that is element of index 1, and the address of index 1 element is 6487588. But when I am advancing PTR by 1, it will not point to the next element, it will point to the 6th element, because ARR, that pointer PTR, is basically pointing to an entire array of consisting 5 elements. So automatically it will advance 5 into size of each element, that is for 20 bytes. So the result is, look, 584604. You are advancing 20 bytes, so 584 plus 20 will give you 604. So hopefully you understand what is the meaning of pointer to an array. It's basically pointer to an array. Instead of pointing to a single element, a pointer can point to an entire array. So that can be declared by, in this way that I already discussed. In this way we can declare, and it is very much useful for the purpose of multi-dimensional array. And this is the proof. This program is basically giving us, let us understand what it actually does. If we increase PTR by 1, it will not point to the just next element, it will point after 5 elements, that means 6th element, if there. We'll coming to this point later on once again with different example, but right now try to understand. If we increase PTR, it will not move to the next element, it will move to the 6th element, that's because it is pointing 5 element at the same at a time. So it will move 20 bytes. Coming to the next example, almost similar, but we are trying to show different things over here. First part is as similar in the previous program. That means we have declared a normal pointer variable in star p, Second point, we have declared a pointer to an array. That means ptr is a pointer to an array, which is basically points to an array of integer, and the size of the array is 5. And I have declared a 1D array of size 5, initialized it 11, 22, 33, 44, and 55. This part we have done in the last example also, p equal to arr and ptr equal to arr. Now, what I am doing over here, try to understand. P equal to %u, ptr equal to %u. What it means? Both are giving the same result as previous, because both is actually pointing to the p equal to 0. P is actually what? ARR, address of ARR 0, whereas PTR is also pointing to the starting of the entire array. That means that both will give us the same result, same address. Second case, star P, star PTR, star PTR. Try to remember the last class when I discussed about pointer to pointer. When I've discussed about pointer to pointer, star P is very much clear. Star P is actually value at index 0. But what about star PTR? Will it give the value at index 0? No. It will return, it will give you the address of 0th element. It will give you the address of 0th element. Try to remember star PTR, rather star ARR in my last class. So this star, as because this PTR is pointing to the entire array, so what is the meaning of this star PTR? Is it the value of the entire array? No. It will give you the address, it will give you the address of what? At index 0. Look, first execute. Let me show the output of this 2 lines. Then I will come back again to the next 2 lines. Let me share once again. Hopefully it is visible to you. So look, for the first line, P and PTR both are giving the same result, because P equal to ampersand AR at 0, value is 6487584. Very nice. What about PTR? It is basically pointing to an array of size 5. So definitely it stores the starting address 6487584. Nice. When I am talking about star P, definitely it will give the value at index 0, because indirection operator star is used over here. Because P is storing the address of index 0. So when I am putting a star before it, that means it basically returns us the value at index 0. Hopefully this much is clear. But in case of PTR, if we put a star before it, what it will give? PTR is pointing entire array. So if we put a star, will it give the value of the entire array? No, definitely not. So what it will give? It will give us the address. If we put a star before it, it will give us the address of index 0. That's why again the same result, 6487584. Previous result was it is the starting address of entire array. Now it is, when I am writing star PTR, now it is giving what it is giving? It is giving the address of 0th index. Next 2 lines. Coming back to the programming page. Yes. So This two line is clear to us, hopefully. There is PPTR. One is the value of P and PTR, and second line is giving the value of star P and star PTR. Hopefully, this two line is clear to us. Line number 11 and 12. Look, it is size of P and size of star P. Size of PTR, size of star PTR. Try to understand. What is size of P? What is size of P? Size of pointer variable. What is size of PTR? Definitely again the size of pointer variable, because both are two pointer variables. First one is normal pointer variable. Second one is pointed to an array of size 5 and both are integers. What is size of star P? Definitely when I am putting star, it is basically returning as the value. So we are actually printing four values: size of P, size of star P, size of PTR, and size of star PTR. So size of P, very surprisingly, gives us how much? Very surprisingly, it gives us 8. Size of PTR also gives 8. Size of star P, what? It gives 4. What is size of star PTR? It gives 20. Among this 4, I hope this too is clear to us. Size of star P, that is 4. Why it is 4? Because it points, star P means the value, right? So when it points to a particularly value, size of star P means we are talking about a value. So definitely the value is integer, and here integer takes how much byte? In depth C++, integer takes 4 bytes, that we know. So that's why result comes 4 byte. It's very clear to us. Next output, size of star PTR. It is a pointer variable. When I am talking about star PTR, it's actually giving us the size of all five, because it is a pointer to an array which is pointing to an array of size 5, and array is an integer array. So definitely 5 elements, each are taking 4 bytes. So definitely size of star PTR will give you 20 bytes. Clear. But this too, question is, how size of P and size of PTR coming 8? What is the rule behind it? What is the logic behind it? Note it down. The concept is pointer in C holds the address of variable and points to the value stored at that address, that we know. Pointer in C holds the address of the variable and points to the value stored at that address. On 32-bit machine, size of pointer is 32 bits or 4 bytes. Write it down. On 32-bit machine, size of pointer is 32 bits or 4 bytes, while on 64-bit machine it is 8 byte or 64-bit, regardless of what data type they are pointing to. They have fixed size. So that is the logic behind it, the output coming. Both are giving 8 bytes. Why? Because it's a 64-bit machine. 64-bit machine, I am executing the program. And both are pointers. So pointer itself, the size of pointer variable itself is 32-bit or 64-bit. It depends upon the machine, how many bits machine it is. And it is regardless of what data type they are pointing to. If it is integer pointer, that means it is pointing to an integer variable. It is a float pointer, it is pointing to a float variable. That doesn't relate. That is not a matter of the size of a pointer variable. That is, there is no relation between the size of pointer variable and what it points. Regardless of what data type they are pointing to, the size of the pointer variable is either 32 bits or 64 bits, depending upon the machine bit size. If it is 64-bit machine, so it's 8 byte. If it is 32-bit machine, it's 4 byte. So that's why the result coming here is how much? 8, because it is a 64-bit machine. So I hope this much is clear to you. This is basically fundamental concept of pointer to an array. Instead of a single variable, it is pointing to an array of size 5, 10, 15 that needs to be declared. Fine. Coming to the next example. I mentioned earlier that it is very much useful, matlab, pointed to an array. This concept is very much useful for a multi-dimensional array concept that I just told when I discussed about this pointed to an array topic. So here we are trying to visualize it, how pointed to an array works for a two-dimensional array. In the last class, I already mentioned that a two-dimensional array can be considered as a collection of one-dimensional array. Look here, in this program, I have considered, rather I have initialized a two-dimensional array, row size 3, column size 4. Elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can, point is, we can consider this two-dimensional array as a collection of three one-dimensional array, and each of these three one-dimensional array consisting 4 elements. Am I right? Yes, because 3 row is there, each row consists 4 columns, so we can interpret it, this is a collection of 3 one-dimensional array, and This can be considered as three one-dimensional array, the collection of three one-dimensional array, and each of them are basically consists how much? Four elements, right? In the very next line, what I have done, I have considered a pointer to an array which takes star ptr4. Look, it's a star ptr4 and it is initialized with arr. That means what it means? It means ptr is basically pointing to array arr. Try to understand. ptr is pointing to array arr, but ptr is not a only one array, rather only single pointer. ptr is a pointer to an array. So that's why what I can say ptr is not pointing only one single element. Instead of it, it can point four elements at a time. Right now, according to our previous concept that we learned just now, we can say ptr is not a single, not a pointer of type to point single variable. Instead of that, we can say ptr is a pointer variable which can point an array of size 4, and definitely an integer array of size 4 because it is in star ptr4 that I declared. So what I just mentioned, I have considered an array of 3 row and 4 columns. Basically it interprets as it's a collection of 3 1D array, each of which has size 4. Right now, if you look it in the linear manner or linear fashion, because the memory address is in linear fashion, so we can say it is stored 1 2 3 4, then 5 6 7 8. First row 1 2 3 4, then second row 5 6 7 8, then third row, that is 9 10 11 12. In this way the array element stored, and ptr is your pointer which is basically point to the first array. When I'm incrementing ptr, it will point to the next array, that is 5 6 7 8. When I'm incrementing once again the ptr, it will pointing the last array, that is 9 10 11 12, because each ptr is pointing to an array of size 4. So we have just crossed the 4 elements. When I am moving ptr, ptr will cross the 4 elements. It will again point to the 5th element, again point to the 9th element. In this manner it will proceed. Fine. So first part what I have done, just prints the array elements along with their address. This part I have just printed the array elements. Look, I'm executing the program. Yes, look, this part. Not I'm coming this part later on. Just so now 1 2 3 4 5 6 7 8 9 10 11 12. Look at the memory address: 68 72 76 80 84 88. It's 92 96 600, then 604 608 and 612. This is the linear manner. Now hopefully it is visible to you. Let me share once again. Yes, fine. This is the memory address of the array elements. Only this part I am just talking about. I am coming this part later on. Now, after this part, what I have done, I am printing ptr, ptr plus 1 and ptr plus 2. That is the point just I talked before execution of this program. ptr is pointing to the 0th 1D array. If you increased it, ptr will point to the first 1D array. If you increase it again, ptr will point to the second 1D array. No? Execute the program and show you the output. PTR is pointing first array, that is 6487568. When I am incrementing PTR, matlab PTR plus 1, it is pointing to the first 1D array. And what is the address of it? 6487584. And when I am writing PTR plus 2, it is actually pointing to the third 1D array, that is 6487600. Hopefully this much line is clear to you. Fine. What is star PTR1? Sorry, star PTR. Just this concept just I discussed in my last program. It is pointing, if you print star PTR, yes, I have just printed star PTR. It will print the address of what 0th element of 1D array. If I print star PTR plus 1, it will print the address of 0th element of first 1D array. If I print star PTR plus 2, it will give us the 0th address of what 0th address of second 1D array. So what is the 0th element's address of first 1D array? That is 6487568. Yes, this is coming. What is the address of 0th element of first 1D array? It is 6487584. Clear to us? And what is the address of 0th element of the third one, rather second? That's because the index starts from 0, so 0, 1, 2, second row. Index 2 row. Actually, it is third row. So index is 2. So what is the 0th element's address of index 2 row? That is 6487600. Yes, it is coming. So that is the meaning of star. If I put one more star outside of this, so definitely it will give us the value of that 0th index. First, in case of first, it will be 1. In case of second, it will be 5. In case of third, it will be 9. And it is coming. I hope this much is clear. If star PTR is pointing to the 0th element of 0th 1D array, and the address is 6487568, if we put one more star before it, so definitely it will give the value at 6487568. How much value it is? It is 1. So that's why the output comes 1. And in the same manner, we are getting the output, the value 5, the value 9 for the next two rows. Star star PTR plus 1 and star star PTR plus 2. I hope this much is clear to you. Second, star star PTR can be visualized as star 1 bracket parenthesis, just like this, star opening star PTR plus 0 bracket close plus 0 bracket close. Right now, PTR plus 0, this part, PTR star of PTR plus 0 plus 0, that can be interpreted as star PTR1. What it actually, it's actually PTR of 0, 0. PTR of 0, 0. So if we write PTR of 0, 0, I will get the value 1. Try to understand. Star PTR, it is 1. That's clear to us. If I write star of star PTR plus 1 plus 2, what is star PTR plus 1? Try to understand the meaning. What is the value of star PTR plus 1? It is basically pointing, star PTR plus 1 is basically pointing to the 0th element of first 1D array. Plus 2, we are moving to the column. We are star PTR plus 1 actually pointing to the 0th element of first 1D array. That is this one, 6487568 plus 2 plus 1 plus 2. We are at this point. Now if we put one more star before it, so definitely it will give you the value, and the value is 7. Try to understand how the 7 comes. How this value comes 7. When I'm writing star of PTR plus 1, actually PTR plus 1 is pointing to the first 1D array. 0th 1D array is pointed by PTR. When I'm writing PTR plus 1, it basically points to the first 1D array. When I'm writing a star before it, it means it is basically pointing to the what 0th element. It is basically points to the 0th element of of first 1D array. Which one is the 0th element of first 1D array? That is 6487584. This is the address of 0th element of the first 1D array. Then I am adding plus 2 with it. So that will definitely give us plus 1 plus 2 here. 6487592. That is the value of star PTR plus 1 plus 2. That is the address. If we write a one more star before it, it will give us the value, and definitely the value is 7 of this address. And the same justification for the next output. PTR plus 2. What is PTR plus 2? What it does? PTR plus 2 is actually pointing to the second 1D array. Second matlab index 2 1D array. When I am writing a star before it, it actually points to the 0th element of second 1D array, index to 1D array, and that is the address of this one, 6487600. If you print the value of star PTR plus 2, you will get 6487600. Then plus 3 plus 1 will give this address, plus 2 will give this address, plus 3 will give this address, 6487612. When I put a star before it, so that means star of this address 6487612, that will give us the value 12. So as we know as from the earlier class, what is the meaning of this? This means actually PTR 23. This means actually PTR 12. This means actually PTR 00. So in this way, pointer to an array can be used for a multi-dimensional array, and it is very much useful in the concept of multi-dimensional array. In this way it can work. Fine. Now I am coming to the topic which is actually need to be discussed earlier, but I haven't discussed it due to this reason, because after discussion of pointer to an array, it will be more easier to us to explain. That's why I not yet discussed it earlier. The topic is how the array first in a function. We have already know the calling part of, rather passing an array to a function, and we have accessed the array elements by pointer in last class, rather last lectures. But today, instead of pointer, if I want to use the array only, then what will be the syntax? That I need to know. So the first example that I am going to discuss now, it is passing 1D array to function, and the second example is passing 2D array to a function. So this is passing 1D array to a function. It's very simple. Try to understand. like this is a function average. The average function is taking two parameters. One parameter is, first parameter is what type of, it is basically uh, taking an array of integers, and the second parameter is integer only. First one is the array of integers, keep it in mind, and second one is the only integer. And this is the alternative function prototype declaration. It means we can give the identifier name here, that we know earlier, that we discussed earlier, that we can provide the identifier name in this case also at the time of declaration. But without providing the identifier name also, we can declare a function just like this. Fine, this much as we have no problem. Second, what we have done in the under the main function, we have taken input for the array, which is x20, and n is the number of element, because we are not taking the all 20 inputs, and the value of n should be less or equal to 20. And I have, after taking input, I have called the function this average. I have called the function this average. Fine. When I'm calling this function average, look the syntax of this calling. I'm passing the array name, and second parameter is the size of the numbers. The size of the numbers. What I know about array name regarding pointer concept, we know basically the array name is a constant pointer which actually points to the array of index 0. So x means it's basically ampersand of x0. Right now, array name is nothing but a constant pointer. This concept we have. Fine, nice. So this average function is basically returning the average of the array elements. That's why the return type of the function is float, and I'm storing the return value inside average, and I'm printing the avj value over here. Now, coming to the function definition part. Look here, I have declared a variable int a of array type, but I haven't provided the size. The size, in case of one-dimensional array, this size is, providing this size is optional. You may write the size, you may not write the size. Fine? Because what is the basic concept here? The concept is, when you are writing it's an array variable, it's actually what you are writing. You are writing a constant pointer, na? And when you are passing a array name in average function, that means you are passing an address of an array, the base address of an array. So the address x, address of x0, and the address of a0 that you are passing from main is basically same. And if you do any changes in the array elements of a, it reflects in x, because you are changing in the same address. I'm showing you. Before that, just do the average. Initialize the variable sum, weighing n0 to less than n, summing all the elements. Then I am just typecasting it, because this is an integer array. So integer by integer, if sum is integer, sum is considered as integer, right? N is also integer. So integer by integer will give us an integer value. But as per the rule of typecasting, we know integer by integer definitely will give us the integer, but the average value of an array, because there are n number of array elements here, so average value cannot be integer. So that's why we have explicitly typecasted the sum. So sum becomes float. This is the explicit typecasting of sum. Sum becomes float, and now if you do a division operation, float by int, rule of implicit typecasting says lower data type is automatically converted to the higher one. So n automatically becomes float. So float by float will give us the result float. So that's why you will get a result float. And this result float value will be returned from the function's average, and you are getting basically print that value in this using printf statement. So first execute this program, then I will modify it. Number of elements, say 5. 1, 2, 3, 4, 5. The average is 3 because 5 plus 4 plus 3 plus 2 plus 1, it is actually 15. Fine. I hope you understand this much. So the concept is, when I am passing an array, 1D array, to a function, the size in the case of function definition for 1D array is optional. And basically the concept behind it is, when I am passing an array name to a function, basically we are passing a pointer, because we know the array name is nothing but a constant pointer which points to the base address of an array. So if we make any changes in A, that must reflect in X. Look, say I'm changing for I equal to 0 to I less than n, I plus plus. Now my array name is what? A, not X. X is in my main array. In the main function, the array name was X. But here my array name in this function average, my array name is A. So I am modifying the value of A here, just like this. A of I, look, A of I plus equal to, say, 10. What it means? It means I am incrementing each element by 10. My point is, this modifications of the array elements must reflect in the main. Why? Because actually we have passed pointer. Call by value is not happening here. It is called by reference, or rather called by address. So the modifications that we have done in the A array, actually we are doing in the X array, because both address is same. A is a pointer, that's because A is an array. Array name itself is a pointer. X is a pointer. When I am passing X to A, that means A and X both are pointing to the same memory address. So if we print the value of X over here, after we are executing the same loop, after execution of this function, look what will be the output. Let me check. Five, 1, 2, 3, 4, 5. Average is 3. Fine. Hopefully not yet saved. That's why output is not coming. Average is 5. Fine. Then I have to print. Oh, sorry. Scanf. Sorry, very sorry. It should be printf, no? That's why the output is not coming. I want to show you the modified value is reflected in X. That I want to show you, because we are actually passing the address in terms of an array, in terms of an array name, better to say. 5 array elements is 1, 2, 3, 4, 5. Look, average is 3. After that, 1 becomes 11, 2 becomes 12, 3 becomes 13, because I have modified each and every element, adding 10 with each and every element. So I have modified it 1 plus 10, 11, 12, 13, 14, and 15. But I have done this modification inside array A. Still it reflects in X. That is my point to highlight over here. I have modified the array elements of array A, but it is highlighted in X. It is reflected in X because array name actually passed over here as a form of pointer. So this is the way through which we can pass an array to a function. Second example is passing a 2D array. This one is the example of passing 1D array to function. Second example is passing 2D array to function. When I'm passing 2D array to a function, just like this, what it is actually doing, yes, look, you have to write this format, void. The return type of this function is definitely void. Hmm. The name of the function is display. The name of the function is display, and the parameters of this function, first parameter is float array. It's a 2D array. M not provided for the not provided the size of first, uh, that is row size, but I have given the size of the column, that is 10, and that is mandatory. In case of 2D array, or rather in case of multi-dimensional array, I have already written it over here. The second dimension must match with the original array declaration, and you must have to provide the value of the second dimension. In case of two-dimensional array, you must have to provide the value for the second dimension. First dimension is optional. You may give, you may not give, but the second dimension is very much important to us. Why it is very much important, that I am coming to the explanation. And the second parameter is normal integer value. Again, coming to the main function, declared a matrix, name of the array is matrix of 10, row size, column size 10, uh, taking the number of array elements depending upon n. I've taken the input from user, and this actually display us the array elements, rather matrix elements. So I have passed the array, rather 2D array, to function display in this format. Array name, once again, array name. Try to remember it. Try to understand it. I'm passing again array name only when I'm passing 2D array to the function. Yes, I'm passing a 2D array named matrix in main function. I'm passing this matrix 2D array to the function display, where the array name I considered as M. First dimension is optional. You may or may not provide, but the second dimension is mandatory. And another point that is, you must have to note it, that I have already mentioned at the starting of this program, the second dimension must match with the original array declaration. In the original array declaration, the second dimension size is 10. So that's why in case of formal definition, rather in case of declaration also, I must put the array size, rather second dimension size is 10. I hope you understand this much. Then using this n, I'm just printing the array elements of mij. Fine. Let me execute the program. Then I'm coming to the backend concept of this program. Say I'm putting the value 3. Actually, square matrix I considered. So that means 9 element I have to enter. I hope function is working fine. I hope this function is working fine. So question is how it works. How it works. When I declared a m2d array in function display where first size is not mentioned, rather first dimension is not mentioned, but I mentioned the second dimension, and I already discussed that first dimension is optional but second dimension is mandatory. Through this we are basically declaring a pointer to an array of size 10 float values, and it is initialized with the base address of the original 2D array. Am I clear to you? Again I am repeating. When I am writing it, float m, this 10, it means m is nothing but a pointer to an array. Pointer to an array just I discussed. Then I am entering into this topic because this is the reason that's why I discuss this topic after so many days, because function we learned, array we learned, but passing array to function, I'm discussing this topic after so many days because this is the reason, because we have to know how it works. What is the working principle behind it? The working principle is when I'm declaring a float m2d array of this, it actually means I'm declaring a pointer to an array of float size 10, and it is initialized with the base address of the original 2D array. Now try to map it. So it is pointing to a 0th 1D array of 10 elements. What is the 10 size basically? 10 is nothing but the column size. So what is the meaning of the column size? The meaning of the column size is the, actually if we think about a 2D array as a collection of 1D array, the size of column size is basically the size of first 1D array, size of second 1D array, size of third 1D array, size of fourth 1D array. In this way, the pointer will move, the m will move. So if you increase m by 1, actually it will move to the next row. If you increase m by 1 more, it will point to the next row. That I already discussed earlier example. How pointer to an array works for a 2D array case. Same principle works over here. Same concept works over here in the backend that we can't understand. That's why I'm telling the point, which is very mandatory for us. We need to pass the second parameter, rather second dimension size. We need to declare. Otherwise, in backend, the pointer to an array cannot be defined with the size. This size is actually meant the pointer to an array size, nothing else. So that's why the second parameter is important. So this is how we can pass a 2D array to a function. I hope this much is clear to you. Function array passing, 1D array passing to a function, 2D array passing to a function. That portion we have discussed. So in today's class so far we have discussed what pointer to an array and passing 1D array to a function, passing 2D array to a function. Now, the last topic, whether today's last topic that we are going to discuss, that is pointer to a function. What is pointer to a function? Each and every function, because before coming to the pointer to a function, we must have to know that each and every function has its own address. Each and every function has its own address. So we can consider pointers that can contain these addresses, right? Now, if a function has its own address, then as a conclusion, what we can say, we can consider pointer that can contain this address. This address means the address of the function. And hence point to them. What is the syntax? The function pointer declaration syntax is this: function return type, function return type. Within bracket, rather parenthesis, this is the star pointer name. Within bracket, function argument list. Try to understand what is the meaning of this. This is the general syntax I have written over here. Function return type. Try to understand function return type. Within bracket, star pointer name. Within bracket, function argument list. So very next line, I declared a function pointer. Int star fp int comma int. What it means? It means here fp is a pointer. Note it down. What it means? fp is a pointer that can point to any function. fp is a pointer that can point to any function that returns an integer value and accepts two integers as argument. Again, I am repeating. What is the meaning of this line? Star fp, it's a function pointer, it's a pointer variable. We know what is the meaning of pointer variable. A pointer variable is a variable which can store the address of another variable, but function pointer is not storing the address of another variable. Function pointer is basically storing the address of a function, because we came to know each and every function has its own address. That is the point. So it's because the function has its own address, so definitely we can store that address in a pointer variable. That is our basic fundamentals. So here I'm declaring a pointer variable, rather function pointer. The name of the function pointer is star fp, rather fp is the name of the function pointer. What it means? It means it can store the address of a function, such a type of function which can return an integer value and can take two integer value as argument or as parameter. I hope you understand this. What is the meaning of this line? Hope you can understand. fp is a pointer, such a function pointer, which can point such a function. That function has two integer parameter and the return type is also integer. Now, in this program, what I have done, I have considered a function. Name of the function is sub, which is taking two integer parameter int a and b and returning an integer, that is the subtraction of these two integers, a minus b. Very nice. It's a very simple function, nothing complex in it. Now, when I am writing actually fp equal to fub, when I'm writing fp equal to sub, that means fp is now pointing what? Pointing to the function sub, because I declared fp such a way that fp can point a type of function which can take two integer and can return one integer. Sub is that type of function which is taking two integer as a parameter and returning one integer value. So fp is very much eligible to point the function sub according to the declaration. So that's why if I write fp equal to sub, that means fp is pointing to sub. Now I am calling the function not by using the function name. Instead of that, I am using that function pointer. Look, function pointer fp and with the parameter 5 comma 4, and this function pointer definitely calls, because I have this fp is pointing function sub. So when I am calling this function sub through fp and I am passing the parameter 5 comma 4, the function will do accordingly its task, and it will return the value, and the return value will be stored inside this variable result, and I am printing it. Am I clear to you? I am not calling this function sub directly, rather I am calling sub through a function pointer fp. So I hope you can understand what is the meaning of function pointer. Function pointer is a type of pointer which can store the address of another function, because we came to know that each and every function has its own address. Suppose I declare one function pointer char within bracket star func underscore p, third one, rather function argument list. Inside function argument list we have written float comma char. What is the meaning of this? Meaning of this is func underscore p is a pointer that can point to a function returning char and accepting float and char as argument. I'm writing that line so that it will be clear to you. Say I'm writing char star func underscore p. This is the name of function pointer that must be written inside bracket, and the third part is float comma char. What is the meaning of this? The meaning of this line is, write it down. func underscore p is a pointer that can point to a function. Which type of function it can point? It can point to a type of functions which is returning a char and accepting float and char as argument. So I hope you understand what is the meaning of function pointer. Here the function sub gets called through function pointer fp, and it will definitely give us the result. How much it will be? 5 minus 4, definitely it will give us 1. Let me execute the program and show you the output. Yes, the result is coming and it is 1. I hope it is visible to you. So using function pointer we get the result 1. So in this way we can call the function, right, by only fp and within bracket the parameters. Now we are going to discuss the last example of today's class. That is functions address. We came to know each and every function has its own address, right now? That we came to know, and using function pointer we can store that particular address. Now we are going to discuss that functions address can be an argument of another function. Try to understand. A function's address can be an argument of another function. Better to say, a function can be passed to another function by using function pointer as a parameter. A function can pass to another function as a parameter through this concept of function pointer. So that is the point. Function address can be an argument to the other functions. Just show the example. Showing you the example. I have used it. Look, I have declared two functions. One is void f1 float. Another one is void f2. It's very normal function. For the second case, void f2, first parameter is int, second parameter is a function pointer. Again, I am explaining the meaning of this part. For the first function f1, it is taking only one parameter float, and it returns nothing. That's why return type is considered as void. For the second case, means in case of function 2 f2, the first parameter is integer, but the second parameter is neither integer nor float nor character. It's a function pointer. And as per declaration that we just learned, it can point to a function which is taking, it can point such type of function which returns void, means returns nothing, and accepting or taking one float value as a parameter. So this fp can easily point a function f1, because f1 is such a type of function which accepting one float parameter and returns void. Am I clear to you? fp is a type of function pointer. Again, I am repeating. fp is a type of function pointer where which type of function it can point? It can point a type of function which returns void and can accept one float as a parameter. So according to this rule, this function pointer is very much eligible to point f1, because f1 is a function which is returning void and taking, or rather accepting, one float value as parameter. This is my f2 part, main part, rather main function. I am calling the function f2 as because it is returning void, so nothing to store here, nothing to store over here. First parameter is integer, so I am passing an integer value. Second parameter is function pointer, so that's why we need to pass a function over here. So I passed f1 because I mentioned earlier that f1 is a type of function which can be passed over here, and this pointer is eligible to store the address of f1. Yes, that's true. because it matches the syntax declaration of fp star fp. It matches with the syntax declaration of f1. So as a second parameter, we are passing function f1. So that is the point. We are passing a function as an argument of another function, and a function pointer plays the important role over here. Now look what it actually does. So definitely when the f2 is being called, f2 gets called from main function, the pointer comes from here to here. This function definitions of f2. When it comes to f2, x gets replaced by value 15 and star fp. That means this function pointer is basically pointing f1. Very nice. So so when when I'm writing int of x, when I'm writing int of x, what it gives, what it gives, definitely it will print the value. It will print the value. How much? That's x value 15. So 15 gets printed. The 15 gets printed. Next, what I am doing, I'm calling the function star fp with the value 10.5. With the value 10.5. Try to understand this meaning. Try to understand this meaning. In the earlier slide, earlier program, I have called it by this. Actually, this should be, you may write this, you may write this in this way also. Star of fp equal to sub star of fp 5 comma 4, star of fp equal to 5 comma 4. Fine. We know what is the meaning of indirection operator on pointer variable. fp is basically the address of the function. Star fp means the function itself. We are calling the function with the parameter 5 comma 4. So it gives us the value. Yes, that's one. Let me share. So it gives us one. Fine. Similarly, in the second example, where so I'm calling this functions, I try to call the functions f2. So this function pointer star f, and I'm passing a float value here, 10.5. I'm passing a float value here, 10.5. So I'm passing a float value here. So what it will give? It will definitely call this function because star fp is basically pointing f1. So definitely this function gets called and the y will be printed. What is the value of y? It is 10.5. So y gets printed, the 10.5 gets printed. So one output is 15 and the another output is 10.5. Let me execute the program. Yes, first output is 15 and the second output is 10.5. Let me share. Understood? So this way that I want to say, a function can be passed as a parameter of another function, can be passed as a parameter to another function, and function pointer plays an important role over here. So before concluding my session, I want to highlight some of the points of regarding function pointers. So I'm sharing my screen so that it will be visible to you. Yes, I hope the screen is visible to you. So these are the points, that is interesting facts regarding function pointer. First point is, unlike normal pointers, a function pointer points to code, not data. So typically a function pointer stores the start of executable code. That's very clear to us. Function pointer is basically pointing a function. So that means it is not points to any data, rather it points to a start of executable code. Point number two, unlike normal pointers, sorry, we do not deallocate memory using function pointer. Yes, very true. Point number three, a function's name can also be used to get function's address. For example, in the below program, we have removed address operator in assignment, and we have also changed the function call by removing star. The program still works. Again, I am highlighting this point. A function name can also be used to get function address. Fine. So that's why in this example, the two examples that I discussed earlier, look, uh, at the time of at the time of function assignment to the function pointer, I haven't used ampersand, but if you use ampersand, it means the same thing, that is address of that function. So you can omit it. Similarly, when we discussed the first program first time, I haven't given any star fun ptr. Later one I modified this because these two are bit similar. If you give this star of function ptr with this parameter 10 and without star, this two is give you the same result. So that's why it is mentioned a function name can also be used to get function's address. So we removed this ampersand operator in assignment, and we have also changed the function call by removing star. The program still works. So that gives us the same result, but explicitly if you want, if you can mention it, star fun underscore ptr, just like I modified the first program later on, but initially I haven't given the star fun, rather this program. I'm talking about this program. Let me share once again that program so that will be clear to you. Look, this one, this program. Later on, I have this sub. Yes, later on I have given this star fp. Initially, I was just written fp fp this. Yes, it's worked fine, and this also gives you the same result. But original syntax needs to be this one. But if you omit this star, it will work fine. Similarly, at the time of assignment, if you give ampersand sub, sorry, ampersand sub, it works fine. Without ampersand sub, it works fine. But normal syntax needs to be ampersand sub because ampersand address of I am talking about. If p is the function pointer, which is basically storing the address of function, name sub, so that's why it needs to be ampersand sub. But if you omit sub, ampersand, it works fine. So that is the third point mentioned over here. Fine. And the output comes in the third point is 10. Third point corresponding example, it gives us 10. Like normal pointers, we can have an array of function pointer. That example I haven't discussed. Try to your own. Function pointers can be used in the place of which case? Yes, that's true. Write your own. I haven't discussed. And the last point, like a normal data pointer, a function pointer can be passed as an argument and can also be returned from a function. I have already shown you that function pointer can passed as an argument, but I haven't shown any example regarding the returning concept. You may try it your own. So this is the detail of function pointer. I hope you understood. If you have any doubt, you may ask through mail. Thank you. Thank you very much for your patience.